Today I thought I'd show you how it might look like when I'm using AI to help with developing Secrets of Grindea. It's a game with a very large, very old and very real codebase, and the work I'm showing here today is actual work. The overarching task at hand is adding split-screen local co-op to a game that until now has only had online multi-machine co-op. Here inside the game I have stumbled upon a perfect bug to show you guys. If I go to this bookshelf and interact with it, I read a book. But as you can see, even though only player 1 is interacting with the bookshelf, the book appears in both parts of the screen. That's no good. When I run into a bug like this, depending on the nature of the issue, I'll fix it manually in Visual Studio, or I use AI to fix it. I think this bug will be perfect for the AI to tackle, so let's have it do just that. So what we're looking at here is a tool I call Codex Wrangler. If you're familiar with Godot, you probably immediately notice that it is indeed made in Godot. The tool is basically just an organizer of any command line AI. In this video, I'm running it with GPT 5.2 Codex. To get going, we'll first create a task. Let's give the task a name. Local co-op, bug fix, books shows on all screens. In the task description, I'll be just a tad more clear. Fix the following local co-op bug. So what happens now is that the tool will spin up a separate Git worktree, so the agent can work in isolation and won't look up my main environment. And let's actually create a second worker, which will do the exact same task. For non-trivial tasks, it's usually worth having at least 2 of them. Now, as you can see from the prompt appearing in the console window, the tool will insert the general context around my task description, so I don't have to copy-paste the same explanations over and over. Instead, I can just focus on writing the unique aspects of the tasks. Okay, so now these guys are both going at it. Usually when I work, I move the terminal windows onto my second monitor and keep playing, looking for new issues, or I do something else that needs my attention. But for the sake of this video, let's just keep one of them up, so you can see it working. And I'll go do some fishing. Okay, our agent has reached the finish line. Judging from its output, it seems like it understood what to do. Now let's see for ourselves how it did. First off, we should quit the game currently running in the Visual Studio debugger. And now we'll start the game inside the agent's workspace. Since building the game is part of its validation criteria, we can just start the game right up and verify. And will you look at that? It works! Excellent. Let's double check to see if it works for both players. Yep, it does. Now, if we were YOLO coding, that would be that. But let's be sane and actually look at what it's done for us. For this, we'll head back to the Codex Wrangler and take a look at the git diffs. Usually I just do this in the good old git GUI, but if I want better context, I open it in VS Code. Alright, so yeah, most minor bugs like this will be caused by the game assuming that there will only be one player and one viewport per machine. So a lot of things work against various singletons. The foundational work for getting local co-op rolling was essentially to move these systems into this helper class, local player container, so each player could work against their own set of systems. It follows that the second part of that work then becomes to connect this new way of doing things with the game's various subsystems, like the book reading. I'm not sure why it has decided to keep track of the number individually like this. Will be interesting to see. It's removing the singleton assumption here, which makes sense. Some new helper functions, nothing dangerous. Okay, so here it uses that extra int. This could be done with just the container reference itself. I'm guessing it started with the int and along the way realized that it wouldn't be enough, and then wanted the entire container for the input, and then just never refactored the extra int away. But that's fine. At this stage of development, this class doesn't have to make perfect sense. This works and is not dangerous. In the standard prompt, I tell the AI that if it finds the nature of its contribution to be valuable to future agents, it should note that in the documentation. This here is nothing new under the sun, so I'm going to reject this addition to keep the agents file high density. Let's have a look at how the other AI tackled it. Right off the bat, we can see that it only changed one code file. And yeah, it didn't add that extra integer either. It just used the local player container helper itself. So while I do agree with keeping that extra integer out of it, I would say that keeping this singleton-like initialization is a bit lazy. It's basically saying we're never going to create one of these in a shared circumstance. It's only going to happen as a result of isolated player interactions. Now, I know that this assumption is actually true, but I honestly doubt that the AI has done due diligence to make sure that's the case. I think here it's just picking up my bad habits, or bad habits from training data. Now, theoretically, one could spend some more time here by polishing one of these solutions and making it more clean, but we're talking about a bug fix of a minor isolated system in a 15-year-old codebase. The pragmatic choice now is to just move on. Since we've already tested the other build and verified it as sufficient, we'll just stick with that. So now that I'm happy with the AI's work, I can complete this task by first committing the changes into the work tree and then merging into the main branch, like so. And well, that's basically it. I know I've been pretty thin on the details in this one, but I didn't want to bog down the video with too much technobabble, just share what the process itself looks like on a surface level. I'm anticipating two questions a lot of viewers will have regarding the use of AI. The first is, how much does this improve efficiency? And the second would be, have you tried to automate the process? When you first try programming like this, you're going to feel like your efficiency has skyrocketed. But then a feeling creeps in that you're not actually as souped up as it feels like. If you're going to review the code it writes, well, you can never transcend that limitation. And when you look back, the commit log seems kinda normal. I did some hobby science, comparing 5 2-hour work blocks without AI and 5 2-hour work blocks where I gave all issues to Claude or Codex. Then I compared the resulting code edits afterwards. A twist that spiced up the experiment a bit was that I also recorded how I felt in terms of clarity and energy before starting the sessions. The takeaways turned out as follows. If I was energized and clear-headed, I got more done working without AI. If I was foggy or tired, the sessions with AI were better than being tired without it. Take these results with as many grains of salt as you find appropriate. This was not by any means rigorous science, but it does match my general feelings about it. I feel obligated to also mention that for some tasks the usefulness is off the charts high. For example, when I wanted to convert my old text input code, which was Windows only, I could write a couple of very simple prompts that turned a whole pile of boring human work into half a minute and some tokens, right? Which is, of course, insane. There are a billion more things to say on this topic, but in short, after developing a good intuition for when and how to involve AI, it does add a lot of value, but not quite as much as you'd think, or even what it feels like. Also note that what I've said is from the perspective of working on Secrets of Grindea. Okay, let's look at the second question. Have I tried to create an autonomous process? The answer is yes, I have tried.
Yes.
With varying approaches. The most autonomous version, the holy grail as it were, is to let one tier of agents look at the code at a high level and identify issues that it then delegates to other workers. And this works in the sense that issues are identified and changes are made, and probably most of these changes are reasonable. But then a portion of the changes are made from flawed assumptions. Sometimes critically flawed assumptions. The AI is often confidently confused and will lay out reasons for changes that sound very good when described, But when you actually analyze them, you realize that it's trying to fix something that either doesn't have to be fixed, or might even break something if done the way it suggests. And the time it takes for me to review and test these things honestly leads to clearly negative outcomes as compared to doing it the way we did it in this video. So ultimately no, I've not been able to meaningfully automate this process, or really any step of it. There's much more to say about these topics, but the scope of this video has been more than sufficiently covered by now. Thanks for watching, and whether you're watching this due to an interest in Grindea, AI or coding, I hope you got some value out of it. I wish you a splendid rest of your day.